Today we are going to learn a real life example of stack. Let's see how it works. So now let's see how a stack works, right? You see now that when you put the bangles here, you put the first bangle, second bangle, third bangle, and fourth bangle. But if you have to remove first bangle, you cannot, right? You have to remove the fourth bangle, then the third bangle, then the second bangle, then the first bangle. So now let's take an example of a stack class. Let me declare a class here. Uh, Stack example. And what I'm going to do now is that we are going to have a stack collection. I say stack, my stack is equal to new stack. And the new stack example, whatever we have, I'm just declaring a stack here. And then it needs, what do you need to import is java.stack.util. So the first example, what I showed you of the stack is a very simple example of, how the stack data structure is implemented. Now, stack has certain classes, which I wanted to explain. And so let's see once again what I meant. Uh, this is the element goes first in, right? Whatever you want to insert is called as first in. And what happens is that when you want to remove, you remove the last out. So the stack data structure follows the first in, last out. It's a LIFO, it's called as LIFO. Now we open the stack. What I'm going to do is that I'm going to store something in the stack, my stack. So what method stack has that we need to first see. Let's Google and see stack API Java, stack API Java. So as we said, the stack represents the last in, first out stack of objects. And what met what all how is the stack structure made? So if you see this stack class stack, it is inherited from vector. That means stack extends vector. And what is inherited from the class vector is capacity, increment, element count, element data. Then the method summary, you have the following descriptions. You have something known as empty method, peek method, pop method, push method, search method. So now what are we doing here? We are doing a push, right? So that is what it is shown here, that we are pushing a bangle inside the hand, right? So we push the first bangle, the second bangle, the third bangle, the fourth bangle, right? Now, this is the purpose of the push element, is to push an item inside the stack. stack dot push, let's say, pull. Pull. So I declared we are taking the stack example, and then I declared the stack is equal to stack. Now what I'm going to do is I'm going to push some fruits inside this. My stack dot push. Let me push, say I'll push apple first. And then I'm going to push, say, orange. And then what? Any other fruit? Uh, Orange, apple, and let's push maybe let's see fruits. Apple, orange, then mango, then what else? Mango, kiwi. Let's push kiwi. AIW. So now I performed a push operation, and as I told that since we are using this stack structure, it's last in, first out, which means that I have a method which is push, right? I push this. Now I want to pop. So in order for me to pop, how does pop work? My stack dot pop, and I'm going to pop this. I'm going to print this. Println and I'm going to pop my stack dot pop. So is there a method dot toString? Let's see what this is going to show. Okay, there's no need of toString. Let's see what this does print. Let's execute this program. Now I wrote an example to push the stack and I'm going to print this. Let's run this and see what's going to happen. Okay, so kiwi was the last, was put last, and now it is coming in the front, right? Printing the first pop. Let's see. Printing the first popped out fruit. And then I'm going to run this. Yeah, so the first popped out fruit is kiwi, right? Let's see what happens if I pop out again. What do you say? What would be the next one? I will give a minute and then think about it. Yes, you guessed it right. Since you put kiwi at the last, it will print kiwi first and then it will print mango. So this is the operation of pop. So we learned what is pop and what is, push. Now let's see what else the operations are there in the stack. So we have empty method. That means whenever the stack is empty, this will, you know, help us to identify if the stack is empty. And peek is the method which looks at the object at the top of stack without removing it from the stack. That means I'm just peeking it and seeing it. Pop removes the object, peep only sees the object and pushes the item. So now what we are going to do is that we will also, you know, pop the third one, pop the fourth one, and as expected, it will show apple. And after that, what I'm going to do is I'm going to check the status, right, of the stack. My stack dot empty. So let's print this. Dot printpln, and then what do you say here is my stack dot okay status of stack. Of stack. What do you think it's going to happen? Let's see if I'm doing anything wrong. There you go. So after I pop 4 times, it printed all in the reverse order, right? First I got kiwi, then I got mango, then I got orange, and then I got apple. But now the question here is that why I am getting, so kiwi is the last one which went is kiwi. So it printed kiwi first, last in first out. Then it printed mango, then it printed orange, then it printed apple, and then, the status of stack. So this is what we learned about two operations in stack. Let's run this once again. Status of stack as true. Now the next thing what we're going to do is that we saw two operations here. One is the pop operation, another one is a push operation. And then we saw what is how to check if the stack status, right, whether it's empty or not. Now let's go again and see what is peak. So peak looks at the object at the top of the stack, right? So before I pop out, I'll see what is there in the peak. That means what I will do is I will print my stock dot dot peak. What do you expect here? It's going to peak what? Does it peak kiwi or does it peak apple? So the last I pushed is apple, right? So peak what it does by definition. Looks at the object at the top of the stack without removing it from the stack. So guess what it will come. Yes, you guessed it right, that it should show apple. Let's run this program. Yes, but I need to printing the first peak. Peaked fruit. And then I will run this. Yes, so we learned how to implement a stack. We learned the methods. What does push do? What does pop do? Now, before I push, I want to see where is mango or where is kiwi, right? I'm interested in those positions. So let's say before I pushed, I'm interested in seeing where is, my fruit orange. How do I do that? So I do my stack dot search. And what will I search for? I'll search for orange. Printing the position of the search fruit. What do you expect? I'm not push anything and I'm trying to search the position of orange. Okay, it should give me a position. Let's see what whatever I've done is right or wrong. Okay. So orange, it shows third position because it starts from the bottom. One, two, three. So the orange is at the third position. So we learned what is search, what is peek, what is pop, and what is push, and we learned how to implement a stack. Remember that stack is implemented from vector. That is why, since vector is synchronized, even the stack is also synchronized. If you like this video, give me a feedback or click the subscribe button. Thank you. See you in the next video.